let's talk a little bit about these FRVs, flow rate valves, since I've got two of them side by side here, which lets us see how much flow each radiator is getting. And it works the same as a lock shield. You can just twist these to close it down. So I've got these two in parallel here. So if I close one of them down, can you see the left hand gauge go down? That one's now increased the flow rate. So they work the same as lock shields. You can be it's a lot more scientific and a lot more precise. They come with these little caps that go over, and they look pretty similar to regular lock shields with a cap on. So in order to know, how much flow each radiator needs, we need to go back to our heat loss calculation. So this is my heat loss exported from Spruce. You can see the living room highlighted there. It's got about 1.1 kilowatts of heat loss, which is 21% of my total heat loss. And working out as a percentage is useful because the flow rate from the heat pump is constantly changing. So you can see I've just been running the heat pump here. You can see the flow rate is highlighted in blue, running at 27 litres a minute there. It dropped down to 18 litres a minute. Now it's the heat pump, it's the compressor switched off, but we've still got some flow rate. Currently running at 14.6 litres per minute. That's our total flow rate in the primary pipework. So that flow rate will be divided between all the radiators. So if I go around and read how many litres per minute each radiator is getting, the sum of all those radiators will add up to 14.7. 20% of 14.7 or 14.6 here. That comes to 3 litres a minute. And in the living room, we've got 2 radiators. So we need to divide it by 2. So that means that each radiator should be getting 1.5 litres a minute of flow. So now if we go back to the living room and have a look at what we're getting. Can you see the top of the red gauge there? That's the 1.5 litres a minute mark. So we're bang on where we want to be. And I've gone through the process of balancing. For example, the radiator in the utility here we've got a small radiator here, which is really close to where the heat pump is over there. This radiator here, the water was whizzing through here. This one was pushing like over 3.5 litres a minute. So I've closed this one right down so it's only getting a really small amount of flow because it's such a small little radiator. It doesn't need much flow, and the heat loss of this room isn't very big. So yeah, it makes balancing much easier. It takes all the guesswork out of balancing and allows us to do the balancing without having to come back when it's cold. You can do the balancing basically at any flow rate if you just work out the percentage of the heat loss on a per room basis.